Alright, hello, my name is Evan Acosta, and this is hold on, I can't figure out how to present, there we go. Okay, this is my Lab 4 video report on the oscillation of a spring mass system and the energy involved with it. So, for a quick introduction purpose, the overall goal of the lab is to observe the motion of a spring mass system that's oscillating in two dimensions, so the x and the y dimension, and then observing how the energy and the forces of the system change as the spring like moves. Um, so the first thing that you do is plug the video that they gave us into Tracker, and then basically plot the points in Tracker to extract the position data. So I'll show you what that looks like right now. So basically you have this video, and then you can you just track it, and then I use this position data, and yeah, that's what that looks like. So once you did that, you can go ahead and put it into a GlowScript simulation. Um, and that just kind of allows you to visualize the movement and be able to plot all the energies and positions on a graph, um, and then be able to create a 3D model of it. So the reason for all of this is just to show how we can utilize the stuff that we've learned in class about the energy principle, the Newton's second law, kinematics, and all that, just to make assumptions about a real life scenario in this situation where it's got like a spring mass or some kind of oscillation. So there are three basic fundamental principles that were used in this lab. The first one is spring force. It's just finding what the spring force is by multiplying the spring constant by the change in the length, and then multiplying all that by the unit vector of the length. And by calculating this in a calculation loop in the GlowScript simulation, you can use it to describe a lot of different a lot of different things about the system. The second principle that we're using is the energy principle. Basically, the total energy of any given system is all of the components of the energy added up. In this case, it's the kinetic energy of the spring mass system, the potential energy, the potential gravitational energy, the potential spring energy of the system, all added up together to create the total energy. And then lastly, it's Newton's second law, which is used almost everywhere. It describes the relationship between force, mass, and acceleration, where F is equal to ma, and using the kinematic equations which are derived from this, you can predict the motion of an object, and you're basically able to update the position and the velocity of a object, which is what's done in the simulation. So here's some code and experiment screenshots. I'll go into more detail on these later. So observations of the simulation. So finding the components of the energy and stuff like that was pretty easy because I just used the initial components that they gave us in the video. I had to calculate some of them, and then you just plug them into the formulas of the of the energies to find what they are, and then you put them in the calculation loop so it calculates over and over again and then creates the graph. So the most interesting result that I found was the energy graph. As you can kind of see, it basically reflects kind of like exactly the conservation of energy. As you can see, the delta E, the total energy, does not change throughout the entire time. Um, Whenever delta U gravity change, or whenever the gravitational force changes, gravitational energy, I'm sorry, you can see that the spring energy also changes to reflect that and kind of mirrors it to make sure that the delta E doesn't change. So here's the calculations. This is the initial calculations, and then this is the, sorry, no, I had it backwards. This is the calculation loop, and this is the initial calculations of all the stuff. So what does this all mean? Is the energy principle satisfied? Yes, as you can see from looking at the energy graph, you can see it always sums to 0. The delta E stays the same. Um, and then you can see how the relationships between the energy, each energy show how the energy is conserved, like I was talking about, with the potential energies basically reflecting each other. And then the oscillation period estimates. So I just went into Tracker and basically just took these and then estimated how long it takes for one period of them. So these were my rough estimates. So the period of x, the x position graph is longer. So I chalked that up to human error when I'm placing points. I'm obviously not going to get it right in the center of mass every time I do it. Um, and then greater possible resistance due to the shape of the spring. You know, as you can see, it's kind of like longer in one direction, so it has more air resistance in the x direction than it would when just going up and down. And that is pretty much it. I'm going to show you guys the program real quick. I'll just scroll through it real quick, but most of the code was in the thing, and then when you run it, this is what it looks like. I have to choose my file. So as you can see this bouncing up and down. I think I messed up my ball position, but um, you can see how it shifts. Yeah, I did mess up my ball. So the Y position is incorrect, but everything else is right. All right, thank you for watching.